Hey everyone, I'm Abby with Spiceworks, and I'd like to welcome you to today's Spiceworks Partner Webinar, New Microsoft Storage Best Practices for Hyper-V and SQL Server, SMB 3.0 and Scale-Out File Servers, brought to you by StarWind. Before we get started, I wanted to draw your attention to the question box on your screen. Here you can type in your questions, and our presenter will try to get to as many as possible at the end of the presentation. Also at the end of the presentation, we will be announcing the 3 winners of the post-Labor Day prizes, so that $20 Starbucks gift card and that 1-year subscription to Wired magazine. Also at the end of the presentation, lastly, we will be recording the webinar, so if you have to step away for any reason during the presentation, you will receive an email with the link to the webinar in about a week. So now that we have all the housekeeping done, I'd like to introduce you to our presenter today. We have Max Kolomesev, and he is the Virtual SAN Product Manager for StarWind. So Max, whenever you're ready, take it away.
Hey, thanks, Abby. Hi, everyone. Hope everyone had a great Labor Day weekend. Thanks for joining us today. And we're going to talk about some of the new Microsoft storage best practices for Hyper-V and Scale-Out File Server. So just a little bit of the logistics of the event. As Abby already mentioned, we are recording this event, so you'll be able to see it later if you missed some part or you need to step away to do an urgent matter. That all happens to IT. And you can also download the presentation later after the webinar. And of course, watch other StarWind events and activities. Follow us on Facebook, Spiceworks, and Twitter. All right. So let's jump to the agenda of our webinar. So first, we'll see what's the Microsoft way to roll software-defined storage for Hyper-V, SQL Server, partially IIS. Then we'll have a look at 2 main concepts, which are hyper-converged versus compute and storage separated. Then we'll see why SMB 3.0 is Microsoft's future primary network storage protocol. We'll have a look at the Scale-Out File Server general overview, get into some details, best practices, and caveats. And lastly, we're going to look at the Scale-Out File Server cluster approaches. Traditional approach with all those SAS, JBODs, or fiber channel or backend iSCSI versus an innovative hardware-less approach. At the end, we'll have the Q&A session, and Abby is going to announce the winners for Wired and Starbucks gift cards. All right, so a little bit about myself. As already said, I'm StarWind Virtual SAN Product Manager. Previously, I worked in QA and technical support department and StarWind software for more than 7 years. Before that, I worked at the mothership company for StarWind, so it brings me to more than 10 years of storage experience. I've got a wide area of expertise, specifically storage, no wonder. Hyper-converged server virtualization scenarios and VDI architectures. And I also host the StarWind Technical Webinar Series. If you want some deep technical details, feel free to join our focused webinar series to find out more. All right. So you may be wondering why StarWind does a webinar about the new Microsoft storage best practices. The answer is the new best practices, which are Scale-Out File Server, are efficient, easy, and just cool. And StarWind also has ways to make them even cooler. So a bit of a background of Microsoft's way to roll software-defined storage. Previously, I think from 2003, Microsoft's iSCSI target, originally string-based software, was not a part of the operating system. They tried to allow it to be a separate OS. Then it became a role in the operating system. But it's been around for a while, and it used standard iSCSI protocol, was able to feed storage for all applications because block level storage is much more versatile. It helps server-side caching, but that's courtesy of 2012 R2 added. Earlier, that was not available. Also, it has some good caching capabilities with the latest operating systems, but it was a beginning of the software-defined storage path for Microsoft. So at certain point, there should have been something to replace iSCSI target, and this is Microsoft Scale-Out File Server. So the new idea is to use the innovative SMB 3.0 protocol. The primary use cases for SoFS would be Hyper-V and SQL Server. Since these are the two biggest loads, SQL Server is still unvirtualized in a lot of environments, and Hyper-V 3.0 starts to take over, and most of the workloads you would imagine are just virtualized under Hyper-V right now. So Scale-Out File Server is moving in the right direction. The solution also introduces flash caching capabilities as well as SMBRX, which I'll talk about a little bit later. Client caching capabilities are also available for the machines connecting to the Scale-Out File Server. And it also provides more functionality and more ease of use compared to a block level storage, just because it is a file level. And as we all know, file level protocols are much easier to use, much more safe to use. So any misconfiguration you can do will not 100% cause you that harm which could have happened with block level storage. Also, the Scale-Out File Server really proves its name because it can scale up to 16 nodes in a cluster, while Microsoft's iSCSI target can technically replicate the storage just between two servers. So there can definitely be more servers in the cluster, but essentially you can have just two replicas. Now, let's see, go to our next slide. Get a little bit changed here. Okay. There we go. So with the Scale-Out File Server, the typical approach would be to build a configuration like the one you see on the screen right now. So the best practice is to use a shared JBOD backend and use storage spaces, or use a block level backend. Let's say it's your old fiber channel, it's your old iSCSI array, and you just provision it to the Scale-Out File Server cluster, and it gets provisioned to the Hyper-V layer as file level storage. Now, this is all good, but there can be devil in the details about the Scale-Out File Server backend. So let's give a bit of an overview of the Scale-Out Server itself. So as already told, Scale-Out File Server is designed for two most popular workloads, which are Hyper-V and SQL. Provides easy-to-use file-level storage. It is really scalable by design. It has additional performance capabilities like boosting the performance with SMB Direct, which is essentially RDMA access to the SoFS server to access the data, which is really fast and makes the latency absolutely minimal. And using storage spaces and Windows Server functionality, Scale-Out File Server can also benefit from tiering, flash caching, as well as Windows deduplication. Okay. So basically, SMB 3.0 as a part of scale-out file server is the future network protocol for Microsoft. Well, Microsoft sees iSCSI as legacy, and the reason for that is Microsoft can control the specifications for SMB, but iSCSI spec is complex and controlled by community. So any add-ons and changes are simple and easy to implement. Another thing is that NTFS, even with CSV file system on top, is a not true clustered file system by design. So performance with multiple initiators, let's say beyond 2 initiators, for a single run does degrade with the QUIDEP. So file level access provides both better performance and scalability in this case. Now, Microsoft sees more flexibility in ability to scale compute and storage layers independently using commodity hardware and same Windows Server license models. So effectively, it's a good way to reprovision existing Windows licenses, and for Microsoft, it's a certain way of business, providing good functionality with an additional Windows license. And lastly, it's a cost-effective way to scale existing fiber channel and SAS infrastructures. So let's say 10 gigabit Ethernet is used to feed storage to the consumers. No need to invest into expensive SAS infrastructure, and especially fiber channel HBAs, license new fiber channel ports, and deploy new fiber channel or SAS switches, which can also be a pain. And that's where we basically getting to the picture I showed previously. So the SAS backend requires minimum of 4 servers and 3 JBODs. Now, 2 Hyper-V servers, that's obvious. We need high availability on the Hyper-V level, so it's minimum of 2. Now, 2 scale-out file servers in a cluster, out of questions as well. And 3 JBODs, just because Microsoft storage spaces requires 3 of them for enclosure fault tolerance. With 2 of them, you will not be able to achieve true high availability. So essentially, we're looking at deploying a new sophisticated storage backend, which is a set of JBOD arrays, 2 SAS switches, and 2 SAS HBAs in each scale-out file server. Now, this configuration can be simplified by, let's say, using 3 cards in each server, but that's not something you can do with all servers. So if you're reusing your old hardware, you're looking for SAS switches and all the appropriate SAS fabric on the back end. Now, the 3 JBODs on the lower part of the screen, which are now marked with this rectangle, can be replaced with your existing fiber channel array, your existing iSCSI array. So the main idea is to feed block level storage to the scale-out file server, which will later convert it into an SMB share and present it to the Hyper-V failover cluster so it can store its virtual machines on it. Now, for true high availability, you need at least 2 iSCSI or fiber channel arrays, which are capable of this functionality. So essentially, we're looking at 6 units in our rack, or 3 units in each rack doing the highly available cluster. And we get an effective scenario here where compute and storage layers and file server layers are segregated. So you can now expand your storage layer, provide more storage to the scale-out file server, and then provide it to the Hyper-V failover cluster, as well as you can scale compute layer independently if you have enough storage and if you have enough IOPS. And once you scale the two levels, which are compute and storage hardware itself, should you require more availability and more resilience of your solution, you can also scale the scale-out file server level, which is scalable by design, and this one can be scaled up to 16 in this version, and I guess Microsoft is going to expand that limit in the future versions. Now, remember, this configuration here is not just 1 gigabit Ethernet. It can be much better than that, but to support higher performance, you need specific cards which do support SMB direct, and it's essentially RDMA access to the scale-out file server, but the switching and the network cards on the clients as well on the scale-out file servers have to support it. So this brings you into the field of proprietary equipment in your setup. And at the end of the day, even if you have RDMA access to the scale-out file server, you have to make sure that the backend storage infrastructure is fast enough to provide you the performance and not bottleneck the entire storage stack, which in case of SAS right now is limited to 6 gigs per second. There are 12 gigs per second emerging right now, but that's not going to happen as fast as 1 year or a little less. So we'll see this process of updating the SAS infrastructure for some time, like we had it with 1 gigabit Ethernet and 10 gigabit Ethernet. But should we think of using different backend storage fabric, the picture changes a little bit. So let me bring our next slide, which does a comparison of these approaches here. So imagine we could get rid of that gray rectangle and try to use more hardware and have more options in terms of things we want to implement in our scale-out file server. See what it can provide us now with an existing design and what would be the alternative for it. So the table here features two approaches. One is traditional, which is SAS, JBOD, or Fiber Channel, or iSCSI I mentioned on the previous slide, and one is hardware-less, which we're going to discuss just a little bit later, and this slide is going to be sort of sneak peek to that configuration. So storage fabric performance, sorry, forgot the P. As I said, it's either a 6 gig SAS and it scales up to 16 gigs for Fiber Channel storage backend. Now, additional storage hardware is required, so it's at least 2 Fiber Channel arrays or 3 JBOD arrays, depending on what you use. Disk types are either Fiber Channel or SAS only if you use a JBOD, so there is no way to use a SATA. SSD support, well, none for Fiber Channel, or it changes with FC SSD, and SAS SSDs for JBODs. So that narrows down the choice we have for the hardware we can use in our storage environment. Now, we also have additional point here, which is distributed RAM and flash cache. So this is actually array specific, so I would not definitely say none, but your storage system has its own cache, so it would be a good idea to keep that cache coherent. If you're building a highly available configuration, you want your storage system to remain in the hot state if one of the scale-out file servers fails or one of the storage arrays fails. Now with JBODs, that's not really possible because there is no like intellectual hardware in the JBOD. With FC, it is partially possible, but there is an alternative solution which still uses the scale-out file server, but provides you a bigger variety of choice for storage fabric, which is from 1 gig Ethernet to 100 gig Ethernet without any switches, at least in case of 2 scale-out file servers. It requires no additional storage hardware, so that gray rectangle I mentioned on the previous slide is completely moved away. It can benefit from both SATA and SAS drives. This also works for the SSDs, which can be either SATA or SAS, so that makes your choice much wider. You can benefit from SATA SSDs in the workloads, which will not bring them down and still give you the IOPS you want for your environment. And it also supports distributed RAM and flash cache, which is kept coherent between 2 scale-out file servers. And should one fail, the second one will keep up, and the data in its cache will be essentially the same as on the one which failed. So the client will not see any performance impact when one server fails. So here is how this configuration looks like. So we removed the gray rectangle. Instead, we've added some more details to this scale-out file server cluster. So effectively, right now, the 2 scale-out file servers only use their directly attached storage. So I pictured spindles and flash here, just for the reference. As I said, it can be either SAS or SATA. It can be SATA or SAS flash and spindles. It can be PCIe SSD, which is not really possible with JBOD solutions. And it utilizes 2 10 gigabit cards, which are cross-connected to synchronize the data and keep the cache coherent. On the front end, this configuration can support both 1 gig Ethernet and 10 gig Ethernet, as well as SMB direct. But for the SMB direct, I would actually make the interconnect between the servers faster. So the magic software behind this is StarWind Virtual SAN. So the idea we've got and what we implemented here is getting the local storage mirrored and then presented to the same servers as one highly available block storage resource. Then scale-out file server cluster sees this block storage as a single disk, says, okay, I'm going to build my cluster on it. I'll put my CSVs on it, and this way I can do a continuously available file share for my Hyper-V servers. But the trick is that scale-out file server thinks that there is some sort of shared hardware, but in reality, there is no shared hardware. It's essentially just the local storage of each server getting mirrored with every written block of data, and the caches between these servers getting synchronized. So we just got rid of at least 3 more hardware units and proprietary fabric, and this configuration does not really say that, okay, you don't use JBODs and stuff like that anymore. It is a complementary solution. So even if you have already deployed a scale-out file server with a SAS JBOD backend, and right now you're thinking about, okay, I would like some PCIe flash for my SQL Server data, but there is no way I can use PCIe flash with JBOD backend. Right now, with the help of StarWind Virtual SAN, you can. So you just install a PCIe flash card in each of the scale-out file servers and mirrors using StarWind, and then present it to the scale-out file server and later to the Hyper-V cluster. So this is a really elegant solution which provides not only the resilience for your scale-out file server environment, but also more performance and more ways you can scale your storage without actually scaling the back-end storage units. So in case you have two existing, let's say, fiber channels, there are two arrays which are filled up and you need more storage. So instead of using something new, let's say trying to invent a SAS/fiber channel mixed infrastructure where old fiber channel arrays coexist with new SAS JBODs, you could just pack some additional drives into the scale-out file servers, use StarWind to mirror them, and then present them to your application layer. Now, you don't use more hardware, you actually use less hardware. That's why we call this configuration hardware-less. So there is not really no hardware, but there is much less hardware compared to what it could be if StarWind was not used. Okay, I'm not sure I'm going to be doing a death by PowerPoint today, so I think at this point it may be a good idea to look at the questions and start a discussion and questions and answers session. And I think there will be a lot of questions, especially on the requirements for this configuration, as well as some technical details. I'll try to address all of them, but I'm just not sure I will be able to get all the answers from the top of my head. So, Abby, would you remind our audience, please, the additional benefits of our today's webinar?
Yes, thanks. So be sure to get your questions in that question box now. This is the time to ask anything you would like. And in the meantime, I'm going to go ahead and announce the winners of the $20 Starbucks gift card and the Wired magazine subscription. So the first winner is Travis Wilson, James Clay, and Brent Corlett. Those are going to be our three winners today. Look out for a PM from Abby in the community. That's me, or feel free to PM me there, and I'll make sure we get those out to you. So with that, it looks like we've got the first question coming in, Max, and it is, can you give any links to the requirements for 3 SAS JBOD minimum? We had been looking at using just SAS JBOD.
Okay, yeah, definitely. I can, so the question, let's see. Yeah, I think I even know where to send these answers. And the thing is that one enclosure is not fault tolerant by design. So it's definitely supported to use one JBOD enclosure as backend storage, but there is no way to have true high availability with one enclosure in front and two scale-out file servers in the back. It's something called an inverted pyramid of doom, where you rely your compute resources on a non-redundant storage layer, or let's say you have a redundant infrastructure where everything is duplicated, but it relies on just one source of power. So the 3 JBODs, and it also was a surprise for me why 3, not 2, is a Microsoft requirement for so-called enclosure awareness. So when doing storage spaces and clustered storage spaces, you need at least 3 separate enclosures so that failover can happen. If you just have 2, it will not happen properly. So it uses not just mirroring, but mirroring with a witness. So the 3rd JBOD is kept as a witness for the 2 other doing the job.
Okay, great. And then the next question is, does this require a 10 GBE network?
This configuration does not require a 10 GBE network. I would say it's not mandatory, but it's actually beneficial to use 10 gigabit networking. So it can work on 1 gig Ethernet just fine. There is no issue with that. And the basic would be adding 2 10 gigabit cards and cross-connecting them without any switches, just to have a reliable and robust storage synchronization backend. So this would be the basic as well as the cheapest option to create a reliable storage backend. Because the 10 gigabit cards these days are essentially at the same price as 1 gigabit quad ports. So it's really worth it.
Okay. Great. And I'm going to go ahead and click to the next slide just for everyone out there while we're asking these questions to go a little more information on StarWind and how you can reach out to them. Because the next question is it possible to see a demo using StarWind Virtual SAN with scale-out file server?
Yeah, StarWind Virtual Sandbox is actually available, and we're going to configure the new scale-out file server testbed in about just a week. So you can submit your demo requests to our website as well as your sales representative to see how it works, what would be the best way to roll it out, and how to configure it.
Okay, great. And then we'll just let we have a bunch of questions coming in, so just give us a second to filter through those.
Sure.
Get them. Okay. So it says, is a scale-out file server based on StarWind supported by Microsoft?
So the idea is that that StarWind provides an invisible storage backend to the scale-out file server, thereby eliminating the strict requirement to have a dedicated storage layer and having shared storage hardware in the configuration. So as I mentioned earlier, these two products are not dependent on each other, but it is really nice and convenient to have them both at the same time, because it can result in a dramatically reduced hardware footprint for the configuration, where you can use just 2 commodity servers for your entire Hyper-V farm and not use any proprietary equipment in the backend. And even if you have that proprietary equipment, and it's not a bad thing, it's also a very interesting storage protocol. It's good to use. It's also convenient, but there is more way to mix things and add additional functionality when you use StarWind in the back end of the scale-out file server.
Okay, great. Let's see. Okay, one question came through. Can you show us speed differences between the DAS and the SAS JBOD design? Microsoft touts 1 million.
I've seen the question.
That one?
Yeah,
Okay.
yeah, I see the question. So Microsoft tells 1 million IOPS. Is that doable with the starting design? I would say yes, that is doable with the starting design. The only thing is, I think I know what the document is with 1 million IAPS. So the previous 1 million IAPS document was actually made by StarWind software. It was pure iSCSI, no scale-out file server at all. And the newer document Microsoft had on the scale-out file server topic utilizes 3 JBODs, which are filled with DRAM SAS flash, which is really small, and overall environment is built for just one purpose, to show a big number. Unfortunately, when you look at the back end of that configuration, you see that they spawn multiple CSVs in the back end of the scale-out file server, and these are later presented and measured at the same time. So this way the million IAPS performance is achieved. With the basic DAS design, I would say that ideal scenario would be 2 3-unit servers, so you can put any type of storage hardware you want with PCIe flash or SSD flash, SAS flash. And the interconnect between the servers should be at least 40 gigabit Ethernet. Because if we're looking at 10 gig Ethernet, it's something like 230,000 IAPS maximum. So 40 gigabit or 56 gigabit Ethernet, which is Ethernet over InfiniBand, would be even a better option. Of course, this will require additional CPU cycles, but this configuration is doable with 2 servers you can pre-build on industry vendors' websites and get shipped to your office within a month.
Okay, great. And there's a lot of questions being asked just about if they can download the actual PowerPoint presentation. So I just said that if they are available, we will be able to include that in the follow-up email.
Okay, yeah, that is something we are including in the follow-up email.
Okay.
And I'll also modify a few of the slides to add some technical details, because one thing is to see the webinar where I can actually answer any question if there is certain thing which is questionable and can be understood dually. But for the actual presentation, I'll try to add some more technical details and arrange the slides the way you can persuade your CEO and managers and show them what their options are and what's the traditional approach versus the innovative approach. So yeah, definitely that is possible.
Okay, great. And then we have a bunch of questions still in if you want to pop through. One of them I see here, what are the minimum specs on the scale-out file servers?
Give me 1 second. Let me just scroll to this question. Minimum specs on the scale-out file servers. Let me actually see. As far as I remember, the minimum specs are actually dictated by the storage hardware. So the system should have sufficient backend block storage to provide it to the scale-out file server. And the CPU requirement, let me see, I think it was something like Intel Xeon E5 2960, but I may be wrong. And actually, instead of looking for the specific document I had on this matter, you can send an email to support@starwindsoftware.com mentioning this question from the webinar, and I will gladly send you a document which has much more technical details on that topic.
Great.
Okay, and I just saw another question popping up. Is a scale-out file server based on StarWind supported by Microsoft? So the answer would be yes, because Microsoft supports block-level backend storage for the scale-out file server, and StarWind is a block-level backend storage. So we fall under this category, and we are supported.
Great. And if you just want to keep reading through those and knocking them out, that would be great.
Okay, yeah, definitely. Let's see. One more was, what is the Windows version I can use for this scenario? So on the front end, you have the Hyper-V servers. So there are three options. One is the Microsoft Hyper-V server, essentially the free version, which only has the clustering and the Hyper-V features available. So that's going to be the bare minimum without any graphic user interface, but it does the job done. And that's the start. You can also use standard and data center licenses on the front-end Hyper-V server. On this actual scale-out file servers, the scale-out file server cluster comes with standard and enterprise licenses, so I think standard license would be just fine for this. StarWind-wise, we're not dependent on the Windows license, so we can see it even on the free Microsoft Hyper-V server license. So it's essentially a choice of the customer which license to use. Okay, let's see. I had one interesting question, but it lost in the others. Perdone, no español. Yeah, there are some questions in Spanish. Unfortunately, I kind of read Spanish, but I'm not yet there to answer the technical questions in Spanish. Okay. Let's see. Okay, one interesting question here. Why we need to use JBOD anyway? Yet we built up same mirroring with 10 gig cards instead of simple RAID 10 plus fast SSD cache. So the idea of using JBOD does not actually come from StarWind. So this is something I would ask Microsoft. So for me, the idea of using JBOD is convenient because not all servers are built the same, and for a dense environment, you can have a one-unit server acting as a scale-out file server and have a directly attached JBOD to that server, instead of buying a big 5-unit server or ultra-dense systems where multiple nodes are packed with JBODs or external SAS shelves in the same enclosure. You can just use a JBOD and manage it as you want. Also, it has the minimum amount of internal components, so it's easily exchangeable and easily manageable, as well as any maintenance operations. So you just hook it up to the scale-out file server and you're all set. You configure everything else on the Windows machine using the convenient Windows interface instead of going for proprietary interfaces of each specific SAN. So there is definitely an added value in JBOD. The only thing for me which is kind of contradictory is swapping out the backend storage infrastructure with a new proprietary storage infrastructure, which is SAS. Other than that, I found JBODs cool, and it's really an interesting thing to implement. Okay. One more question is, does this work with vSphere? I would say yes, but there is a little star in this answer. vSphere does not really use SMB 3.0. vSphere likes NFS. So what you can do, you can use StarWind on 2 servers, then create clustered NFS share and provision it to your vSphere virtual machine? So the answer is yes. Of course, if you have that kind of an environment, because for the current vSphere versions, there is a really excellent product produced by the parent company, and a lot of customers would be just easier to switch for the native product instead of creating an external NAS solution for vSphere. All right, so I'm starting to lose traction with all the questions coming in. There are definitely a lot of them. Okay, yeah, just found one more which does not duplicate with the others. Is this much like Microsoft tier storage setup? I would say both yes and no. So essentially with StarWind in the backend, you can have tiers of storage on your block level storage. So StarWind manages the tiers and StarWind manages which data sits where. So on the front end, you still see it as a file share, but on the back end, StarWind does all the data management. And if it sees that, okay, that SQL VM is moved all the time, it will keep it in the SSD layer or even in the deduplicated RAM cache. On the other hand, you can use fixed tiers. Let's say you provision some storage of your PCIe SSD card as a separate SMB share specifically designed for your SQL server. And this will be a fixed tier using StarWind and Scale-out file server. Okay, and I guess the last question for today's event, what kind of redundancy we have here and what is the rebuild time? So the answer would be, it depends. The redundancy is one scale-out file server can go out of service and one Hyper-V server can go out of service. This is a little bit better than a more complex environment with backend SAS switches and JBODs, but still there can be options. The rebuild time mainly depends on your storage size, capacity, and spindle speed. So let's say you've lost a complete array and you have to rebuild that array. So we're not really looking at the synchronization speed at this time, but we're looking at the rebuild time for the array itself. As soon as the array is rebuilt, the 10 gigabit networking between the servers can push up to 2.4 gigabytes of data per second. So that gives us a really good rebuild time on the StarWind level.
Okay, great. Well, there are still some questions. So if you didn't get your question answered here live, somebody from StarWind will be following up. So just know that. And with that, Max, I'll just let you kind of close us out with any closing statements, and then I'll follow up with one housekeeping item.
Okay. Yeah. So I think I'll just do the same thing as I do always. So the main idea with all storage infrastructures is plan before you implement. So all these designs are good for specific scenarios, and we don't say that StarWind design is ultimate and it is a panacea for your environment. There are always some options you can consider, and the main idea is to measure the IOPS you require and to measure the availability level you require. Definitely StarWind provides an easy way to achieve that availability and resiliency, but in some cases the RPO and RTO requirements do not really need that level of redundancy. So plan your environment before you go to production and you'll be safe.
Okay, great. Well, thank you so much, Max, and to everyone at StarWind for a great presentation. And just wanted to remind you all that you will get an email in about a week, and that will have not only the recording but also the slide deck with a little more information from Max. So be on the lookout for that. And with that, I just want to thank everyone for attending, and we hope to see you on future webinars.
Okay. Bye, everyone.